Hi everyone, we are pleased to announce you our first sustainability talk. So, as it is the first, we really enjoyed that you share with us where you come from. So please write in the comments your location below. Just to let you know, if you have any questions, write it down in the comment section so that we can answer it at the end of the presentation. I will start to present you the summary of this live. Sylvain, can you just put the summary? Thank you. I will start to share with us the Sustainability Mobility events and our first group international events. Then after that, we will have a quick presentation from Nathanael of the R&D department. And then Nathanael and Pedro will present us the two subjects that they are working on. So let's start with the Sustainability Mobility Challenge. That is a group event. It's a CSR international event, and we are really thrilled to announce you that during this event we have this first sustainability talk. The aim of this event is to promote low carbon mobility and to promote also sustainability topics. And this is why we are right now on live from La Défense Paris, and I will introduce you to Nathanael and Pedro from R&D departments.
Hi Chloe, nice to meet you and nice to be on this live. Well, my name is Nathanael Dugier. I'm PhD in energy engineering, and I work for SII for 2 years as a R&D manager in Paris.
Yeah, thank you, Chloe. My name is Pedro Seger. I am an R&D manager also in SII, but in Lyon. And I've been with SII for almost 1 year now. And so thank you very much for the entire CSR department for inviting us. It's a great pleasure to be here with you.
It's also a great pleasure for us. So please, can we start with the presentation, Nathanael, of the R&D department?
Yeah.
What do you do? Where are you located?
Sure, with pleasure. Probably many of our viewers don't know our R&D department. We have at SII France a department called SII Research. We are around 40 people fully dedicated to R&D to innovate for our clients and also for internal projects. And our projects are divided in two areas, transport of the future and future city. And so currently we are located in 8 cities in France. And so myself in near Paris and Pedro in Lyon.
Thank you so much. So we will start with the DECO project, so the project that is led by Pedro. So Pedro, can you just talk about your project, please?
Thank you very much. So it's a project called DECO, which stands for Decentralized Energy Communities. And so the title is Optimizing Energy in Future Cities. So my idea for today is to explain what energy, what cities. But also I just wanted to, like a disclaimer, we are not going to do a super technical presentation with equations and graphs and all. But if the public has questions, they can ask the questions on YouTube, but they can also contact us later. It's a great pleasure for us to be contacted by our colleagues. So the context of the project, as we all know, there is a growing availability of solar panels and electric vehicles and batteries worldwide. And there's all the global push to ecological and energy transition. And nowadays the electric grid it's ongoing. There's a paradigm shift that is ongoing. Before we had big centrals for producing energy, like a big nuclear power plant like in France, that would produce energy for several cities. Now we still have these big plants, but we also have smaller plants like wind farms and solar, and even at a house level, people can install solar panels in the roof. Also, this project is also motivated, as we all know, by the rising cost of energy worldwide. So right now, especially after COVID, so right now, if you have a solar panel on your roof of your house, you have 3 options. Either you have a battery, so you can store this energy and use it later, or you can sell it back to the energy provider. It's Enedis in France, but every country has a different one. But in France, it's usually at a loss. Usually for private persons, we can buy energy at 20-25 cents to the kilowatt hour. But if we want to sell the same kilowatt hour back, we only get 4 or 5 cents. And there is a third option, which is called collective self-consumption, which is sharing this locally produced energy with the neighbors, with the buildings around you. And this has a lot of advantages. The idea is that this is like a win-win situation. So maybe I can sell you my excess energy for a smaller price than you would pay for the main grid, but I also recuperate more money than I would if I would sell for the main grid.
Okay, so what's the idea behind the project?
Yeah, so like maybe that like why don't we all do this like all the time? So there are challenges in this kind of project. So the first challenge is like regulations. I will give you the example of France. Like you cannot like connect a cable between your house and your neighbor's house. If you want to do collective self-consumption, you are forced to go through like a local association, which is called PMO in France. And there are limitations. You have to be in the same low voltage network, and you have to be like in a 2-kilometer radius, and you need this association. So this project, there are also like research subjects, the challenges, because now if we are going to do like decentralized energy management, we have to do like decentralized operation of the system. So this means that we have to be able to forecast the consumption and the energy production of different types of people and different types of users, sorry. And we also need to optimize this. So we know that maybe tomorrow, who is going to sell how much energy to whom, at which hour, at what price. So this gave birth to the Découvrez project, which is a project where we want to place ourselves as an energy management tool. And right now we are working on 2 fronts, with a third one that's starting to happen. So the first 2 is like the forecasting of the energy production and consumption. And we do this with the deep learning models. And the second one is the optimization and the modeling of the communities. And like the third one, Nathanael will present later, we are starting a subject about the usage and estimating the lifespan of the batteries. Because if you have a battery in your house and you're going to use it all the time to store your excess energy, maybe it will make your battery age faster. So there's maybe something to be studied there.
And why don't we do that then?
So like the challenges for the forecasting model, there are several ones. Like if you want to forecast like the production of your solar panels, like we all know that it's like a variable energy source. So we don't. It's dependent on the weather, on the season. If there's a tree growing beside your solar panel and casting a shadow. Also for the consumption, like you have different types of users. Like usually like. Houses will like have a peak of consumption in the end of the day, but maybe a bakery shop will have a peak of energy consumption in the morning because they're baking all the croissants. You also have issues in data quality and management. You don't always have like real-time good quality data, and you cannot. Well, it's good to have prediction models, but you cannot have like super complex models that will need like a huge computer that will calculate for several hours. There are other, so these are the main challenges. And the proposition, what we started studying in SII in Lyon, first we identified like several open source repositories from thousands of different types of households and users in several countries in Europe. We studied different techniques of forecasting, like mostly machine learning and deep learning. So we compared like a lot of different techniques and we chose the one that gave us the best results. And so now we have initial results, but as I put in the PowerPoint, it's to be continued because it's not definitive. But like I try to put an illustration, like if you have like a real profile, like the one in the blue color, you can teach, like you can make a learning stage on your deep learning models, and eventually, if you feed enough data for this model, it will learn that this user it has a peak of consumption in the morning and a bigger peak of consumption in the evening. So this is for the consumption, for the forecasting.
Okay, this is really interesting. And could you tell us more about the field project and the main subject that you're working on?
Yeah, the other subject is the optimization. Yeah. So if we have predictions, what are we going to do with them? And this also poses several challenges because if you want to optimize something, we need to have like a realistic case study. So we have to model different type of users. Like as I said before, like you have houses, you have commerces, you have like industries. In future cities, you have like a lot of EV charging stations and solar parkings and all this. Not all users are the same. So some people will have like a battery and a vehicle and a solar panel. Some people will not have any of that, but they are all part of the same community. You have challenges in the that are related to the energy grid, like there are some physical constraints. Next, you also have challenges related to computational time. Like you cannot also have an optimization model that will take several hours to calculate. And it also has to be scalable. Like if the model takes 1 minute for 10 users, it cannot take 1 hour for 20 users. It cannot explode in complexity. You have to calculate the tariff, because if you want to sell energy to your neighbor, it has to be a win-win situation. But how do you incite people to do this? Usually it's by with the money. And you also have several types of uncertainties. You have external uncertainties like bad weather. You have internal uncertainties. Maybe you think that the person is going to stay at home, but they will leave, so their vehicle is no longer connected. So this adds a layer of difficulty. So in the optimization part, what we propose right now, what we are studying in SCII Lyon, we also tried to develop a realistic case study with 10 different users. We are recuperating real data from the Energies open data repositories. We recuperate solar energy profiles from also open data repositories, but we have a partnership with a company that installs solar parking systems, so they are also giving us real data. And we did an entire mathematical formulation of the problem that is not included in this presentation today. But just to tease you with preliminary results, we developed a baseline model. And right now, if we compare the optimized model with a base model where you just sell the energy back to the provider all the time, we can have economies of around 20-25%. So I also added some graphs just to give an example. This is one of the results from one of our latest simulations. You have a user that has I think the orange curve is the consumption and the blue curve is the production of this user. So you can see that already it's a user that consumes a lot more energy than they produce. In red, you have the buying and selling from the main grid, and in green with the battery. So we see, for instance, that the optimal operation for this user was to charge the battery in the night with the energy from the grid, then discharge it during the day. And when you have solar power, you use this energy yourself. And there is one thing missing from this graph, but it's the most important part. You buy energy from your neighbors. So one of the gap between the yellow and the blue curve is usually, if it's not in the red curve, it's buying energy from your neighbors. And this, for this user, it made an economy of 20-25% in the energy tariff. So this is what we are working in right now.
How can you improve all the forecasting that you made?
For the next steps?
Yes.
Yes. So right now, as I said, we develop forecasting models and optimization models. Mm-hmm. Now we have to connect them. We have to use the outputs of the forecasting models to optimize. And the idea is to have an end-to-end simulation where we recuperate real data, we do predictions, we optimize, and we suggest energy transactions to the different users. So there are many possible next steps. I tried to list a few in the presentation. We want to compare different approaches of forecasting and of optimization. We have to test the scalability and the robustness of the solution, as I mentioned before. The next one. We want to include the battery degradation. Is a subject that Nathanael will explain better. And finally, most of the projects in SIA research, we try to develop a demonstrator, something visual that we can maybe show at for the clients of the company or at a conference, a salon. So in this case of this project, the demonstrator that we are developing is a user application where the user can see their different profiles of consumption and production, the predictions, and the optimization. So basically, he can see all the results of our work and maybe think, oh, it's a good idea to do collective self-consumption.
That's amazing. Yeah. Maybe you can also share a bit more about this new tool that you just talked about. For your clients, what is the benefits of this tool, for instance?
Well, right now, we are collaborating with some universities and other companies. We will talk a bit more about this later. But usually in this project, we are putting ourselves in the interface between like the users of a community and the main energy provider. So if we are ever to commercialize this solution, or we would address ourselves to clients that are in this business sector.
Okay, and in this tool, is it maybe like somebody in his house who needs to view the consumption of his electricity, or is it maybe more for a company that sold electricity? For who
Yes,
is it?
the demonstrator that we are working right now is like an end user application.
Okay.
So it's like for the real individual person that will be able to see their consumption and the recommendations. Like we suggest that you buy energy at this price, and and then sell it at this price from your neighbors.
Okay.
But of course, if we ever work with like a company that is actually going to implement the solution, there would need to be like an administrator tool for this operation.
Okay, so both sides then.
Yes.
Okay, perfect. That's really interesting, and I think
Thank
it's
you.
an amazing project. And of course, it's not the last one, because you'll see there is also the project from Nathanael, which is really interesting. It's about electric buses and how to charge them and optimize the charging. So go ahead, Nathanael.
Thank you very much, Chloe. I'm going to talk about the eBus project, which is a project we are doing in Paris, and it's about optimizing the electric bus charging. So mainly I'll detail, but sizing and controlling how we charge large fleets of electric buses.
So what are the current issues with electric buses charging?
Well, we'll take an example. Imagine you are a bus fleet operator. So you have an existing bus network, the bus fleet, and the services, which means the daily operation of the buses. You want to have electric buses because they have benefits, such as reducing greenhouse gases emissions, air pollution, or maintenance costs. And you have also incentive regulations that will help you to buy new buses. And indeed, you are not the only one, because we see currently that there is an exponential increase in the number of electric buses. But behind this global figure, what we realize is that for many bus fleets, we only have a small number of electric buses in the fleet. Why that? Because, to summarize, we have 3 ways to charge a bus. Slowly overnight at the bus depot at low power, during the day at line terminals for a few minutes at middle power, or at bus stops for a few seconds while passengers are boarding or lighting at very high power. And for those wondering, the picture below shows how it's recharged so fast. It's with a pantograph like for trains. So the challenge with this recharge is that we have infrastructure that costs a lot, buses, but also charging stations. Also, the electricity prices are quite high, as Pedro said, since COVID. And we have constraints for the power grid, so for example, concerning the peak power, or concerning the operation of buses, for example, the autonomy or the delay for passengers. So the 3 main questions as bus operator that you will ask yourself is, first, where can I install my charging stations, and at which power should I install them? What will be the capacity of the onboard battery? Should I have a big battery but a heavy one or a light one? And then finally, when should I charge or discharge the buses, and at which power?
Okay, so I understand that as a bus operator, you have many issues. So how can you help them with them?
Well, that's the main question of the eBus project. So the project goal is to create a decision support tool with 2 main objectives. One is to optimize the size and the placement of the charging stations, and the other one is to have a smart control of this recharge. So the 3 main parts of the project are optimizing the size and the control of the infrastructures, modeling the bus consumption, and finally, as Pedro said, optimizing the lifespan of batteries, because it can have an impact on them.
Okay, so you just talked about the optimizing the bus charge, but how is it feasible today to charge a fleet that is really large with like hundreds of vehicles inside?
That's the main challenge. Today, for small fleets, operators do that at the depot. But for our problem, we consider that you have a bus network, existing bus network, bus fleet, and bus services. And the goal of the optimization will be to size the charging infrastructure, so to know at which bus stop you have to place a charger, to know the size of the battery inside the bus, and also to control the charging process. But additionally to that, we have another problem, which is the bus-to-grid strategy problem. Behind this technical term is a really simple concept. Can you discharge your buses during the day or night to help the network or do something else? And indeed, we have two options. First one is to participate to energy markets, which means that when you buy electricity when it's cheap and you sell it when it's expensive, basically, or to provide ancillary services, which means that you have a contract with your electric grid operator and to provide, for example, frequency regulation. And the question about bus-to-grid strategies is, can you consider that your bus network with the buses, chargers, is equivalent to a stationary battery that will at all time charge and discharge to the network? And the risk with that is that we're not sure it's technically feasible. Do we respect constraint about the bus network and the electricity grid? And also, is it economically viable? We have many costs linked to the buses, batteries, chargers, and can the bus-to-grid revenues compensate those costs? So the way we're trying to solve that problem is that we first begin with a simulation. We manually determine the location and the size of the charging station, and we have a rule-based strategy saying, for example, if your bus is plugged, you will charge it. Then we have two options. The first option is a two-stage optimization. First, we consider a fixed charging strategy and we will optimize the sizing and placement of the chargers. And then we consider a fixed charging infrastructure and we will optimize the charging strategy. The second option is to jointly optimize charging size and placement and the charging strategy. So this is, we are doing that in parallel currently. And additionally to that, we will add new constraints, such as modeling the energy market, the ancillary services, and additional features like having mixed fleet between hydrogen, electric, diesel buses, having different batteries, or adding robustness, for example, if you have prices that vary. The results of that part will be a tool that optimizes the placement and sizing of the charging station, the capacity of the onboard battery, and the charging strategy with these new strategies that are quite innovative.
Okay, so you explained to us how to optimize all these different categories, but could you help us to understand how the bus consumption influenced this result? Because when I charge my phone, for instance, if I charge it quite too fast or not enough, it's not working that well for the
yeah, well, it's to take an analogy, it's like eating. You have to know how much you're hungry to decide the quantity of food you will eat. Same for buses. You have to know what the bus will consume to know what size of charger you will need. And one problem for us currently is that the bus consumption models are not that precise. As you can see on the screen, bus consumption depends on many factors, mass, drag, driver's behavior. And the problem is that some of these factors are sometimes oversimplified. For example, the HVAC, which means the heating climatization, or the lights. And others are not taken into account, for example, the curvature or lateral wind. So that's a problem for precision. The other problem with bus consumption is that the validation lacks also precision. Currently, validation is made based on confidential measurement made by bus operators. The models are also validated on a unique case study, for example in Paris, but it's not necessarily representative for other cities from our viewer cities, for example. And also all these models are not compared to each other. So how can you say that your model is better than what exists? So the consequences is that model will lack precision, it will lack reliability because you don't know if the model from Paris is could be applied elsewhere, and also you can risk to oversize your charging stations. The way we're trying to solve that is that first we have a problem of, well, accuracy, and we will use a physical approach with detailed models for the main phenomena, the traction of the bus, the air drag, etc. New models for the less common phenomena such as curvature or lateral wind, and also fine resolution of field data that will give us an accurate model. This accurate model would then be reduced using different techniques to have an accurate and fast model that can be used in the optimization I talked about before. The second part is the problem of validation. So for that, I will use a database that is called the GTFS dataset. And it's what is very interesting for us because it's open access, standard format, and it represents the bus network. So to be very short, I will use this, automatically characterize this dataset and identify all the bus paths and gather the slope, curvature, speed limits, intersections of each bus path. And then I will summarize this data and add to that meteorological data, traffic data, and test it on various operational conditions, and I will do clustering to have many different conditions and to generate several case studies. So this part of the project, the results will be an automatic characterization of these files, GTFS files, also a comparison between different bus consumption models, and finally a validation, proper validation on representative case study that we'll share with the community later.
So we've got like a few minutes left, so can you talk about the battery and the lifespans, please?
Yeah, sure. Well, the battery problem, it's like with your phone. If you charge and discharge it, it will affect your battery. So you have many stress factors, the temperature, the charging current, that will cause degradation mechanism, and that will affect your battery with a loss of capacity and a loss of power. And indeed, as we've seen before, when you size your charging infrastructure, it will have an impact on the charging profile during the day, and then on the battery degradation. So the main challenges are to have precise models to suit complex charging profiles, also to update the parameters during the life of the bus, because you can't unplug the battery of the bus or even cut it to analyze it, and then we'll have to control the battery during the operation too. Our approach is the digital twin approach. Probably you've heard that before. The principle is very simple. You have a real object, the battery, a virtual layer with many models, and then between them a communication layer with measured data that will go from battery to the virtual layer, and then a feedback loop where you will compute many indicators in the virtual layer and then control your battery. And it's bidirectional communication in real time. Some functions that we try to implement in this digital twin are the safety function. For example, if you overheat, you have to stop the current. An estimation of the state of charge, so the level of power of energy in your battery, and the state of health, meaning the quantity of energy left in your battery that will reduce with time. And the results, currently we have a good state of charge estimation with a very small error, and we're still working, especially with Pedro, on new degradation models, and the bus is to create an adaptive and modular battery management system.
Okay, thank you for this presentation. And just the last question is that your board project, you work with a lot of stakeholders. So what are the next steps with them?
Well, concerning my project, the next step is to really optimize the charging strategies and take into account these bus-to-grid new strategies, and also to compare the consumption models. We're doing that currently, and to create with Pedro degradation model that is mixed between physical and machine learning approaches, and to implement them on electronic boards, as you can see on the picture. And of course, we are also trying to demonstrate our work to potential clients. If between the viewers you have clients interested in both our project, Pedro and I, we're looking for clients and partners. So feel free to ask us questions and to speak about our project. And for between us.
Yes, just to complete the answer. We have these projects that are like internal to SII, but this does not mean that we work alone. Right now, we already work in 2 different agencies in France. We are effectively, as Nathaniel said, we would like to demonstrate eventually the results of our works to clients and to like conferences, etc. But we are also in collaboration with several universities and other companies in France and in Europe. And thanks to these collaborations, we are entering to 2 cover projects, one in French level and one in European level, with partners from Portugal, Slovenia, France, and both these cover projects are related to batteries. So this is why we have this subject in common. So that's it.
Then thank you. That's 2 amazing projects. I really enjoyed listening to you, and I hope that it is the same for you. So it's now time for the questions. So if you have some, please write it down on the comment section, and I will ask the question to our 2 speakers. Yes. So we've got lots of them. Please, I will start with the first one. So, hello, a lot of bus can do B2G, B2L. For EV car, is it rare today? So I think you need to translate it for everyone, please.
Yeah,
if you
sure.
Understand.
Yeah, sure. So indeed, currently, what I talked about with discharging a vehicle to help the network, let's say, or is something that exists a bit for electric vehicles, so individual cars, but indeed it's rare. And for buses, it does not exist in the real life. That's what we do R&D before, to know if it's technically feasible and if we should do that also, because we're not sure. There is the question of the price, but also the question of battery degradation. If we use much more battery to doing B2G, it's not very good for Earth resources. So yeah, it's not done currently. We have bidirectional charger that are developed, and for the European call, we answer with a partner that has such chargers, but that's really the beginning.
Yeah. And even to complete, like he said, even for EV cars, it's rare today, and indeed it is, but it's changing because we have 2 different standards for charging stations, and newer models of vehicles and of charging stations are starting to become compatible with the most recent standard, which already includes the option to do vehicle to grid.
Okay, so the next one, that the modelization permits to take into account different usage profiles. So that there will certainly show that a mixed population in good scenarios, people living at home, families, industries.
Yes, exactly. I only presented the result for one user of our case study, but the case study that I mentioned with 10 users, we have 6 different house profiles, some with solar panels, some with batteries, some with all. We have 3 different types of commercial profiles. So the profile that I showed you was a commercial profile. That's why the consumption was quite high. And some consume in the morning, in the evening, during the entire day. And we have, in this case study, we also have like a solar parking that is simulated thanks to data from one of our partners. So yeah, you're absolutely right. We have to consider, it's one of the challenges is actually to consider different types of users. And whenever we propose a solution, we have to check if it works for for different cases. Like it cannot only perform in situations where you have like all houses with solar panels or etc. The solution has to be adapted and be able to be scaled to different sizes of communities.
Okay, so if you have other questions, as I just said, please write it down on the comment section so that Pedro and Nathaniel could answer it. Otherwise, you could also write them an email and they will be pleased to answer to you. So I had a question regarding the two of your projects, regarding the battery, because it is where your two projects collide.
Mm-hmm.
So how do you want to work together in the future on this project? Do you have already think about that, or is it still?
Yeah, well, we have already started working together. It's a good complementary collaboration. Pedro is really specialized on battery operation and degradation, and myself more on operating energy systems. So, as it's a link to our presentation today, we work on electric mobility, and it's quite complementary because for all electric usage, you have a battery and you also have the charging problem. So that's why we're working together. Me more on the link with the charging power grid and when to recharge, and Pedro a bit more on battery, but we work a lot together.
Both subjects are related to energy transition. Yeah, that's why we were invited today. Exactly. So we have a lot of common ground.
Okay, perfect. Is there another?
Yeah, there's a question from Salim.
Thank you, Salim, for your question. So, what kind of data does Deco collect and how it is processed?
Yeah, for our case studies, we are trying to always work with real data. We have found several open data repositories. Sometimes they're related to like a scientific article. Sometimes they are available from the energy providers. Here in France, there are two open repositories. One from Enedis, which is the distribution level management company, and one from RTE, which is the transmission level company. So you can get real data. As I mentioned before, we have solar data from also public repositories, but also from a partner company. And yeah, I hope I answered the question. But yeah, how is it processed? Yes, we have to filter, like whenever we recuperate data from different repositories, we have to make special attention that they are compatible, like that they are usually that they have the same time step, like the difference between one point and the other is about the same. That we recuperate the good units, like we want tension in volts, current in amps, and etc. So we have to also do like a pre-processing in any data that we recuperate.
If I can add something about data collection, it's real challenge, especially in the energy and transportation sector, to have data. Most of them are confidential. So once again, if you have in your project in different countries, if you hear about data about battery charging profiles, about, for example, motion profiles for vehicles, buses, we are interested. A challenge for us is also, and especially when we're using machine learning models, is to have enough data and enough diverse data. Mm-hmm. So this is not something easy, and many R&D projects are facing the same issues. Sometimes we have to generate data, so realistic one, but if we have real ones, it's way better.
Mm-hmm. Yeah, and sometimes, just to complete, sometimes there is public available data, but it's not like it's not complete. Like, yeah, exactly. An example is for the weather data. We can recuperate free weather data. We do it every day to see if it's going to rain, if it's going to be too hot or cold. But there are other indicators that maybe we need, like
humidity in the air,
air pressure. And sometimes, if you want to have a real good database for these specific types of indicators, you need to pay.
Exactly.
Always,
yes.
Okay. Okay, so as we don't have another question, I had one because I always have questions. And I was wondering, how did you manage to find the topics of your subjects?
Well, for me it was quite easy. It's from my previous work, my postdoc at university. I used to work on an international project for the International Energy Agency about electric vehicle and photovoltaic production. And during this project, I started working on electric buses and found this topic very interesting. And when I arrived at SII, I talked about this idea, and I had the full support of my hierarchy. So that's how the project started, and then we see that there is interest for other partners, academic or industrial ones. So that's it.
Yeah, and from my side, it's about the same. When I arrived at SII in the end of 2024, sorry, the project already existed for some months before, but it was a project that interested me. It's one of the reasons why I chose to come to SII. And in my previous experiences, like during my thesis or my postdoc, I worked with modeling of second life batteries. So batteries that are no longer good for cars or buses that can be used in less demanding applications. So it was natural for me to choose to work in a company and with this kind of projects because it's my passion.
Thank you. Do we have another question? No? Oh yeah, we have from Albert.
So
no,
it's
it's
many
like,
locations, yes.
Yeah, many locations.
So we have a lot of people from all over the world, so it's really nice.
Ah.
Oh, from
Bogota.
Bogota. Yeah.
Nice.
Hello, Nicolas.
Yeah.
It's something that we really want to do for a long time with the CSR coordinators. So we are really pleased that you are all here to listen to this first sustainability talk. And I hope that will be more of them, of course. No other question right now? Okay, so maybe a last one from my side. Sorry. So I was wondering, so what is the next step between an R&D project and a project that is running for a company? What are the steps that you need to take?
Well, first, during an R&D project, we have to do a proof of concept. For example, if I take the example of best-to-grid services, we have to show to a company that it's something that we can do, that we have the small optimization doing that. And then, if we have the interest of the company, the idea will be to try that on a realistic case study and then on the real case study. That's for the European call we answered. These are the steps. Currently, we know that we can do it, and we try to scale the project to something more ambitious. And that's why also SII is very interesting, because once we have finished, let's say, the R&D part, there is the industrialization part. We have many engineers very capable of doing that, so it's very complementary. First R&D, and then once we have a client, the operations.
Okay, thanks. And we've got a question from Romaric. Do you have in mind the environmental impact when comparing scenarios and solutions?
Yes, of course. No. It's no. Thank you for the question. That's an interesting question, because environmental is not only greenhouse gases. There are many impacts. We have some people at R&D, High Nancy in Toulouse, that are specialized in these topics. And the following of the question, as an example, adding batteries will optimize the data consumption. It's very polluting. Yeah. That's exactly. We try to take it into account. Yeah. Maybe I'll leave you answer on that part.
Yeah. But, and of course, it's one of the things that we can model, and it's one of the next steps for us as well. One of our university partners is like a specialist of life cycle analysis, so the calculation of how much is the environmental impact from a product from cradle to grave. So that is very CSR.
Yeah, true.
And yeah, in our case, for at least for the example of my project, right now we are only optimizing the cost of energy. But one thing that we can also do is model the environmental impact. But for a project like mine, you can take a pretty good guess that if you consume the energy locally, it's going to be less. It's better for the environment because you have less losses. You don't. If you produce solar energy, it's cleaner than like buying energy from a grid that maybe comes from like a thermal power plant. And for your question about batteries, it's a very good reflection as well. It's something that can be modeled, and it's something that usually leads to the usage of second life batteries, which is a subject that that I really like. So sometimes, for house batteries, maybe you don't need to buy a new battery. You can buy a battery that's already been used for a while in an electric vehicle that will cost less and, well, in theory, pollute less because it has already been built. So it's in the circularity of the
Yeah, true.
of the solution. But yeah, of course, if you want to eventually optimize it, you have to calculate like every time you install a battery, what is your like a CO2 footprint per kilowatt hour, and compare it to other solutions.
And also maybe to add something, if you have, for example, for bus to grid services, you have electric buses, so you need a battery inside the bus, that's for sure. If you can discharge your battery, maybe you will need less stationary battery because we have new huge parks of batteries, and if you can provide services using your battery inside the bus twice, once for bus operation, once for power grid services, maybe you will need less battery and then reduce your environmental impact.
Another question. Thank you so much. Do you hire people for those interesting projects?
Well, that's more a question for HR. We're still pleased. Currently, I'm not sure, but probably if there are offers, they will be shared in the SII network. So just stay focused, and if some HR are listening, do not hesitate to share if there are such positions.
For permanent positions, we cannot say for sure because it's not on us. But usually in these projects, at least in Lyon, Paris, and in France, the SII developers that are sometimes between two missions, they can come work at us at the R&D project. So they can be part of these projects for a couple of months, maybe before they go to another mission. And we usually have a good return of experience from them because it's a different kind of project that they would work in a final client. And it also sometimes allows them to discover new techniques, new things.
Exactly.
And just for let you know that we have also internal mobility, and it is quite promoted inside SIA, so don't hesitate to ask your manager or your HR department about it. So this is already the end of our first sustainability talk. We were really pleased to welcome Nathanael and Pedro to present us the two projects that they are working on. And as I just wanted to say that we all have a legacy of really carbon intensive mobility, and these two projects show us that we have also something that we can build and something that we can have as an inheritance and legacy regarding sustainable mobility. So thank you all for joining this sustainability talk, and I hope that you'll be here for the next one. Bye bye.
Thank you.
Bye. Thank you, Chloe.